I want some help collecting guesses, okay? So, let's go to that first table. Guys, start telling me your guesses from that first table. Over there, table 1, 2. Give me your guesses. Start slinging them.
59.
Okay, keep them coming.
64.
Okay.
82. Riley cheated, don't kick her.
Riley,
46.
46.
52.
Mary, 61. Okay, next table.
52.
Okay.
32.
30, 34. Okay, next table.
50.
80, 50, 52. Next table.
50.
Okay.
53.
Okay.
52.
Which one? 42? Last table.
32. 50.
Okay, so as I go through these, I'm going to be looking at how far away they are from the number 47. I missed a table? Oh, Lily's table, sorry. I just... 47? 60? Two more at that table. 50?
89.
Okay, so the next column says... the next column says absolute guessing error, which means how far away is it, right? So I've got a 12, and you guys are going to make me think.
Yeah, you could just go around and we could just say it.
No, I got this. 17, 1, 14, 5, 15, 13, 33, 3, 5, 3, 4, 6, 5, 15, 3, 0, 13, 3, and 42. Okay. So these are all of our guesses and how far away from the guess we are. The next thing I need to do... All right, so along my x-axis are all my guesses. And when considering scale, I need to be able to go to 80, it looks like. Okay, so I'm going to go 10s every other, I think. 10, 20, 30, 40, 50, 60, 70, 80. And that could be...
Yeah, you gotta go to 90.
I gotta go 90. Oh, that's fine. And that's not a perfect scale. I'm only using half of it, but it's gonna work. And then for my y-axis, I'm going from 0 to 42. So I'm gonna go by 5s. So 10. No. What am I gonna do here? 10, 20, 30, 40, 50. Let's go by 10s. No, change it again. I guess 5s. 5s, 10, 15, 20, 25, 30. 35, 40, 45, 50. So my scale isn't great here. The first 2 hours were a little tighter with their guesses, so they were a little prettier. But this is good. This is good. So now I'm going to start putting these points down. I got 59, 12. This is going to be right about here. Okay? Then I got 64, 17. 64, 17 is going to be right about there. 46, 1. Somewhere about there. 61, 14. 61, 14 is going to be right about there. 52, 5. Right there. 32, 15. Right about there. 34, 13. Right about there. 80, 33. Right about there. 53. Right about there. 52, 5. Already had that one. 53, already had that one. 43, 4. Right about there. This is not, I should have chose a different scale. 53.6. Pretty close to right there. Let's go to that 47.0. I'm going to not do all of them now. 47.0 is right about there. And then let's do we already did 32.15. There was 2 of those. Okay. Either way, I'm just going to draw a highlighter. This is not connecting them. Are you guys seeing this general relationship?
Yeah.
Okay, so how would you describe that shape?
B.
So you guys are saying V-shaped.
Or like a check.
In this case, like a check mark, but let's say I had another theoretical, like a 20. A 20 would be 27 away, right? So if we had more guesses, 27 would be like there. What are you noticing about the 2 sides? Troy?
The more like away, like farther away, the higher up.
The further away, the higher up. Okay, that's a good way to put it. Also,
Further away.
like how many numbers are 2 away from 47? 2 numbers are 2 away from 47. 49 and 45. How many numbers are 10 away from 47? 2. 57 and 37, right? So kind of splitting it down the middle, there's like an imaginary line where we have symmetry. That's because we're talking distance away from this 47, and there's going to be 2 numbers that are both that same distance away. Do we do negative distance? No, so that's why this is called absolute value. This is an absolute value. Now, is this a function, yes or no?
No.
Let's take a vote. Who says yes? Who says no? Okay. So let's go over the definition of a function. In order to be a function, each input can only have 1 output. So all of you that said no, which input has 2 outputs then? 50 has 2 outputs. Okay, let's do this. How far away from 47 is 50? 3, 1 output. Okay. Who's got another? So if we had a lot of no's. 52, okay? So 52 is 5 away. Is that 1 output or multiple outputs? 1 output.
Like if you look at it, there's no 2 outputs per input because it's not like this.
Each input has exactly 1 output. So let's take another vote. Raise your hand if you think it's a function. Yeah. Raise your hand if you don't think it's a function. So I think where the confusion might have come is there's some outputs twice, right? Like there's 2 different numbers that are 2 away. But every time you put in 49, 49 is 2 away. It has that means it is a function. It's kind of like this analogy I use. There's a vending machine. The whole vending machine Skittles. You push, no matter what you push, what are you going to get? However, if you push B4, are you going to get Skittles from a random spot? No, you're going to get it from this one spot, B4, every time. It doesn't matter that they're all Skittles. If you push B4, you're going to get it from the one spot. That's kind of like what it means, still a function. All the outputs can be the same in theory. But every time we push B4, we're getting Skittles. Every time we're putting in 2 away, or 47, sorry, we're 0 away. Every time we're putting in 49, we're 2 away. Each input has exactly 1 output. So here's what we're going to do. We're going to use the same data, and we're going to pretend like I lied to you about how many are in here. We're going to pretend like... Oh, no, I got to take that picture again. One sec. I should have just erased it. We're going to pretend like I lied to you about how many were in that jar. And instead of 47, the first 3 tables, so groups 1, 2, 3, 4, 5, 6. I know we didn't mix them up today. 1, 2, 3, 4, 5, 6. You guys are going to pretend like the real answer is 40. And the last 3 tables are going to pretend like the answer is 50. And then we're going to look at and examine how it changed our graph. I'm going to graph these both on here using different colors. I'm going to do the 40 in blue. And so let's look at that. And I'm not going to use your data exactly, but I'm going to look at which point would be perfect then for 40. A guess of what? 40. And how far away would that be? 0, which would be right here, right? And so then just for like theoretically, 1 away would be what 2 things?
39 and 41.
39, 41. They'd be like right here and right here, right? So you could think of 39 would be 1 away. 41 would be 1 away. Okay? Let's just do 5 away next. 5 away from the answer 40 would be 45 and 35, right? So I'm going to go to 45 and 35, and those would both be 5 away. Oops. 32, 4, 5. Got those not in the perfect spot, like right there, okay? So building that out, let's go 10 away. 10 away would be what and what? 30 and 50 would both be 10 away. So 30 and 50. What are you guys noticing? What shape do we have again? We have a V. Like, I'm going to connect them just for a visual, and then I'm going to unconnect them because we don't have everything in between. But in theory, if 40 is an exact perfect, these are to keep going out 1, 2, 3, 4, 5, and so on, right? So, actually, I'm going to keep that connected just for the visual. Just know they're not connected, right? You guys go with that? Now, let's look at 50. If I had one that was guessed 50, for 50, how many away would that be for the 51?
0.
0 away, right? Okay, let's go 2 away. 1 away is kind of hard to see on the graph. 2 away would be the numbers 52 and 48, right?
Yeah.
Both those would be 2 away. So I can go 52, 2, and 48, 2. All right, let's go 10 away next. From 50, I got a 40 and a 60. Those are both 10 away. So 40 would be 10 away. 60 would be 10 away. What are y'all noticing again?
Still V-shaped.
So how would we describe our original? Let's do our original in green. Our original is 46, 47. It went like this, right? How would you explain the shift of our graphs? If we change our actual to 40, the whole thing went left. Is it still the same V otherwise? Okay, keep that in mind. As we switch to 50, the whole thing went right. By how many? 3. Like the amount that it's different to get the perfect guess, right? Everybody seeing that? Same V, shifted left or right depending on what our new thing is. And again, it's always going to be that V in this case because that's how far it is away. Distance is always going to be positive. So, the next thing I want to write with you just for practice, this won't even be on homework, but F, I'm going to use green again, the F of the guess for 40. To get those answers, I'm going to take the guess and minus 40. This is a rule for the green graphs, okay? Let's test it out. Let's say you guessed 39. Put 39 in there. What's 39 minus 40? Negative 1. What's the absolute value of negative 1? 1. So 39 is 1 away. So this is the rule as an absolute value. Let's look at the burgundy. Let's say I said f of g for the burgundy. We know that's 50. So how am I going to see the difference between what's guessed and 50? X minus 50. The absolute value of that. It's always going to be positive. And then our OG original, the green, it would be f of g equals x minus 47. Those like lines on the outside are absolute values. Now, reminder, with the order of operations, where does absolute value happen? There's stuff inside of them. So think about that when you're thinking gems. There are numbers. So your options are grouping, exponents, multiply, divide, subtract, add.
I would say
Yeah. Zeph's saying grouping because I'm taking the absolute value of this thing minus this thing. So you got to do the subtraction first. One thing once in a great while I'll see someone do wrong. They'll treat that negative 40 as a positive 40. It's not a positive 40. You'd have to do your subtraction first. Absolute value is a grouping symbol. So you have to take care of what's inside first. All right?